Welcome to Study Loop.
So in this problem, we are given with the reaction equation for the formation of hydrogen iodide from hydrogen and iodine. We are given the value of Kc for the equilibrium, and then we are also given the volume at which the reaction is taking place. We are given the masses of hydrogen, the equilibrium mass of hydrogen and iodine, and we have to find out the equilibrium mass of hydrogen iodide. So we can so how we can do this is first you have to set up the expression for the equilibrium constant Kc, and from there we can see that if we set that up, we will see that the expression of Kc is equal to, for this reaction, the product concentration over the reactant concentration. So it will be the concentration of Hi. It will be squared up since the coefficient of Hi is 2, and then we'll have to put this over the reactant concentrations H2 and I2. Now from here what we can do is, so now here we know the value of Kc, and we can find out the value of H2 and I2 concentration from their masses, and from all these values we can find the concentration of Hi, and from the concentration of Hi we can find out the mass of Hi. So first step here will be to find out the concentration of Hi, and so the concentration of H2 and I2 from their masses given, or which is their equilibrium masses. So using these masses we will find out their number of moles first, and then using this volume we will find their concentration. So number of moles of H2, first we'll have to find out the number of moles, which will be the mass given, or the equilibrium mass given over its molar mass. So the equilibrium mass of hydrogen is given as 0.056 gram over its molar mass, 2.06 gram per mole, and this will give us the number of moles of hydrogen, which is 0.028 mole. And in the same way we can find out the concentration of hydrogen just by dividing this number of moles by the volume of the reaction vessel, which is 2 liter, and this will give us the concentration of hydrogen ion at equilibrium. Now, so the hydrogen gas at the equilibrium, that will be 0.014 mole per liter or molar. So this is the hydrogen gas concentration at equilibrium. Now the same way we can find out the number of moles of iodine just by dividing its mass by molar mass. The mass of iodine is 4.36 gram, and its molar mass is um, 253.81 um, gram per mole. And from there we can find the number of moles of iodine, which will be 0.017 mole. And similarly we can find out the concentration of iodine just dividing this number of moles by the volume of the reaction vessel, which is 2 liter, and this will give us the equilibrium concentration of iodine, which is 0.008 mole per liter or molar. So now we have find out the equilibrium concentration of hydrogen and also the equilibrium concentration of iodine. Now plug in these two values here in this equation and also plug in the value of Kc, we can find the equilibrium concentration of Hi. So if we just rearrange this reaction equation to find out the equilibrium concentration of hydrogen iodide, it will be Kc times hydrogen ion concentration, hydrogen gas concentration, and iodine concentration. So here we know the value of Kc, which is given as 55.3 times the hydrogen concentration we have calculated just as 0.014 m times the concentration of, or the equilibrium concentration of iodine, which is 0.008 molar, and from there this will give us a value of 0.079 molar. So this is the equilibrium concentration of hydrogen iodide. Now we have found the equilibrium concentration of hydrogen iodide. Now just going back, we can find out the mass of hydrogen iodide. So from the concentration of hydrogen iodide, we can find the number of moles of hydrogen iodide just by multiplying um, that concentration by um, by the volume. As we know that the concentration is basically the number of moles over volume. That means the number of moles will be equal to the concentration times volume. So we will just multiply the equilibrium concentration of hydrogen iodide by the volume of the reaction vessel to get the number of moles of hydrogen iodide. So it will be 0.079 molar or mole per liter times the volume of the reaction vessel, which is 2 liter. And from here we'll get a value of 0.157 mole. So this is the number of moles of hydrogen iodide, and from here we can find the mass of hydrogen iodide. As you know that the number of moles is equal to mass over molar mass. That means mass will be number of moles times molar mass. That means it will be 0.157 mole times the molar mass of hydrogen iodide, which is 127.91 gram per mole. And from here we'll get a value of 20.13 gram. So this is the mass of hydrogen iodide at the equilibrium for this reaction.